Hey, how's it going, guys? This is Nitrogen here, and welcome back to Science Explained. Today, we're talking about rockets. What is it? How they work? Its history, and some remarkable rockets. So, without further ado, let's dive into the topic then. So, rockets. Some of the best engineered machinery humans have ever done. They're defined as a missile, spacecraft, aircraft, or other vehicle that obtains thrust from a rocket engine. Rocket engine exhaust is formed entirely from propellant carried within the rocket. Although it sounds very disgusting and all, I can simplify this so you would understand better. So, rockets are a type of stuff that shoots very hot things at the back to push other things forward. Great, a very not professional definition. Still, jokes aside, rockets are some serious engineering. If you see a rocket, especially rocket engines in real life, you will say the same thing. The mechanics of a rocket is shown here. A rocket consists of mainly two parts, the propellant and the engine. Now, if you ignore the outer structure of the rocket, you will find it to be true. The propellant consists of the fuel and the oxidizer, since without oxygen, fuel cannot burn in vacuum. Normally, rocket engineers use cryogenic liquid oxygen as the oxidizer, since it is very dense and, well, it is oxygen. There are also not so popular ones such as ozone, fluorine, sulfur, or hydrogen peroxide. For fuel, there are some choices: kerosene, liquid hydrogen, and methane. These are what the majority of rockets use as fuel. However, there is another category of rockets called hypergolic rockets, which means they ignite without a heat source. Examples of this type of oxidizer fuel combo are dinitrogen tetroxide and hydrazine. The use of dinitrogen tetroxide and unsymmetrical dimethylhydrazine on rockets such as the Proton rocket or the Ariane 1 made it quite famous, although this horrific toxicity might contribute to its fame. These are all liquid fuels, but there are other fuel types that have some advantage in some terms. These solid propellants, normally used in solid rocket boosters or SRBs, is purely solid and good for providing lots of power. There are also hybrid rockets, which consist of a solid fuel and liquid or gas oxidizer. Done with the fuel, let's go to the engine. Like I said, they are the most finely engineered machinery humans have yet to see. It was built, tested, and operated with intense precision, and even thousands of calculation error may cause a catastrophe. Now, a traditional rocket engine, when I say traditional, I mean the Bell nozzle engine, use sort of converge and diverge mechanics. To be simple, the fuel and the oxidizer was pumped into the combustion chamber using some pump. They ignited and expand in volume. The expanded gas flowed through the narrow part of the engine called the nozzle. At this stage, the fuel was the fastest and has the highest pressure. Then it was directed through a bell-shaped nozzle. This is when the exhaust flames generate thrust and push the rocket up. Now, the history of rockets can be sourced back to ancient China. Ancient Chinese used gunpowder as propellant, and these rockets were first used as weapons in the Song Dynasty almost 1,000 years ago. But that is not the modern fancy rocket that we see today. The start of a real modern rocket is around 1926, when a lovely guy named Robert Goddard invented rocket with a supersonic nozzle and using liquid as a fuel. The true modern rocket was born. Although this rocket is nothing compared to today's rocket, it didn't even put anything into orbit, it still provided an inspiration for future rocket engineers. So, right after the Great Goddard, in Nazi Germany, a new rocket engineer appeared. He's one of the legendaries. His name is Wernher von Braun, one of the 20th century's best rocket engineers. He had designed various rockets that are still remembered today. For example, the infamous V2, the first strategic missile made by the Nazi Germany and was designed by von Braun. After the fall of Nazi, he went to America and designed America's first satellite and its rocket. Just a few years later, he has started designing his Saturn series rocket, overcoming combustion instability, which is why the Soviet counterpart of Saturn V failed, and designed the most famous and biggest rocket in the world, the mighty Saturn V, still the most powerful rocket and the only rocket that is able to put men and women on the moon. He died in 1977 at the age of 65. Of course, Mr. von Braun was a genius and designed some fancy rockets, but we must not ignore his competitor on the other side of the globe. Meet Sergei Korolev, the Soviet chief designer. Personally, I liked him more, not because he's a communist or von Braun was a Nazi, but because during the Cold War, although these rocket engineers have similar output results, Korolev, however, had a tighter budget, been to the Gulag, suffered authority issues, and his rockets were more reliable. And I dare say, they looked more adorable and smart, which is definitely not why I liked him. He had designed some supreme reliable pieces of rocket, one of the most legendary ones being the R7. It is first designed to be an ICBM, or Intercontinental Ballistic Missile, but later decided to modify the design and make an orbital rocket. It was first launched in 1957, and the improved version of the rocket is still in use today. This family of rockets had a total of more than 1,900 launches, and is currently the only rocket in the world that can launch astronauts into the ISS. Since the SpaceX Dragon capsule was not in commercial use, the legendary R7 had lots of variations, from the original ICBM to the Sputnik launcher, which launched the first man-made satellites into space, then the manned Vostok, Voskhod, and Soyuz carrier vehicles. After the fall of the Soviet Union, the R7 family was taken by Russia, and in the 21st century, they have developed their more efficient and reliable variant of the R7. What a legend! Other than the R7, Korolev had also designed the N1 rocket. If it was successful, it might have beaten the Saturn V and became the most powerful rocket in the world. According to plan, N1 is going to be a beast, with a staggering 30 NK-15 rocket engines just on its first stage. Going up, you got 8 engines at second stage, 4 at the third stage, and some other small upper stages. However, right after 4 launches and none succeeded due to funding, government pressure, combustion instability testing issues, and Korolev himself dying, the project was cancelled. Following the heat of the space race, as a part of the Cold War between the Soviet Union and the United States, other countries have also dug into the arena and started their own space program. The British have modified the ICBM, the Black Knight, into the Black Arrow, nicknamed the Lipstick Rocket. The Black Arrow was quite okay, but the British government still cancelled it. Right following the Soviet track was China. In the middle of its Cultural Revolution, the Chinese space program gained lots of support from the Soviet Union, and they have sent a lot of specialists and personnel into China to help them develop their own rocket. Although they had a sort of a rough start, they soon became one of the most capable rocket launching countries in the world. Despite using hypergolic propellant, which are extremely toxic, and sometimes crashing their used boosters into wild mountains. Other countries such as Japan and India also have their own space programs. Now, all of these rockets we talked about are state-owned and are funded and ran by the government. But how about private companies? There are a lot of private companies involved in rocket design and engineering too. SpaceX, one of the most popular private rocket companies, and is famous for its reusability and friendly cost. Blue Origin, a company focusing currently on commercial space tools using its New Shepard reusable rocket. Rocket Lab, a company making small orbital rockets that are cost-friendly. And there are many more companies have joined the rocket industry too. Now, there are a lot of rockets that's worth spending time to talk about, but unfortunately there's just no time. Hope you guys have enjoyed this video, and make sure to smash the like and subscribe button, and don't forget to turn on the notification bell so you won't miss any more awesome videos of mine. Thanks for watching, and see ya